Hello and welcome to Maths with Mr Amison. In this video I'm going to be going through a goal-free problem to do with angles between parallel lines. Start off with, what can you tell me about this shape here? Pause now, see how much you can tell me. Alright, there are a number of things that you can calculate in this shape, a number of things you can recognise. First thing to recognise is that we have an isosceles triangle and we have a parallelogram. Alright, because the lines mean that AD and BD are exactly the same length, so it's an isosceles triangle, and the arrows on the lines mean we have parallel lines. AE is parallel to BC and AB is parallel to EC. If that's the case, that helps us with a number of things. Because of the parallel lines, we can recognise that the angle here is 70 degrees because it is alternate to the other 70-degree angle that we are given. Once we've got that, you can see because we've got an isosceles triangle, the base angles of this triangle are at the top. Therefore, the angle up here is 70 degrees as well because base angles in an isosceles triangle are the same. Because we know that, we can then get that this angle down here is also 70 degrees because that is alternate to the angle that is in blue. Once we've got that, we can also recognise that opposite angles in a parallelogram are equal. So the angle in the top right corner totals 80 degrees, so the angle in the bottom left corner also totals 80 degrees. You can recognise all three of these angles by recognising that they are all in a triangle, and angles in a triangle sum to 180 degrees. Right, so that's plenty of angles, lots of information there. So what was the original question? This question was to work out the angle BCD. It's worth recognising that when you have an angle written in this form, that the letter in the centre tells us where the angle is. BC and CD are the lines that make up this angle. So B to C to D, if I draw those lines, then it gives me my angle in this corner right here. So we figured out that that was 100 degrees. Now, how could we have done that in a more efficient way than calculating every possible angle? Well, we could have done this. We could have first recognised that the angle at A, the green angle, is 70 degrees, the angle DAB. Then we can recognise that the angle at DBA is also 70 degrees using the base angles. Then we could have recognised that this angle here was 70 degrees by using alternate angles. And then this is a triangle, so we could use 180 degrees in a triangle to get that that angle is 100 degrees. We could also have done this, recognised the first two the same again. The angle at DAB is 70, the angle at ABD is 70. But then if you didn't recognise this angle here as alternate to up here, you could have done opposite angles in a parallelogram are equal. Angles in a triangle add up to 180, so this is 30. And then these are opposite angles in a parallelogram, so this would have to be 100. We could also have done this by, again, the first two steps being the same. But then this is 40, because its angles in a triangle add up to 180. Then this bottom line is a straight line, therefore this has to be 70, they add up to 180. And then this is in a triangle, therefore this angle has to be 100, so that they add up to 180. So a number of different ways of solving this problem, but I hope you can see that just figuring out things that you can really can help you get to an answer instead of having to worry about what the question is asking you to do. Just find out things that you know, and then that can guide you to answer the question properly. Thanks for watching. Speak to you soon.